Hey everyone, welcome back again to Figuring Cloud with Jackie, where I'm documenting my journey as I learn cloud while leveraging my knowledge in networking. If you did not catch my introduction video, it's linked in the description box and somewhere here on the screen. Go watch it so that you can understand what I am up to. Let's get right into today's video. Before I dive into cloud networking, it's important to just go through the traditional networking concepts that cloud is built on. So this is part one of a 4-part mini series where I'll go from basics of networking all the way to the introduction of AWS networking. Let's start with the foundation, the TCP/IP model. Now, you might have heard of the OSI model with its 7 layers, but in the real world, we primarily work with the TCP/IP model, which has 4 practical layers. As you can see on your screen, the first layer is the application layer. This is the top layer of the TCP/IP model and the one closest to the user. This is where all the apps you use, like web browsers, email clients, or file sharing tools, connect to the network. It also manages things like data formatting, so both sender and receiver understand the data, encryption to keep data safe, and session management to keep track of ongoing connections. The second layer is the transport layer. The transport layer is responsible for making sure that data is sent reliably and in the correct order between devices. It checks that the data you send, like a message, a file, or a video, arrives safely and completely. This layer uses 2 main protocols, TCP and UDP, depending on whether the communication needs to be reliable or faster. The third layer, the internet layer, it is used for finding the best path for data to travel across different networks so that it can reach the right destination. Think of it like a traffic controller controlling flow of traffic in a busy road. It helps data packets move from one network to another until they reach the correct device. Network access layer, layer 1. Data is prepared to be transmitted to the destination. This is where you'll find actual cables, wireless signals, and electrical impulses. To continue on our analogy, think of it as the roads that traffic travels on. Let's look at an interesting fact. When your data is sent, it travels down this stack. Each layer adds its own header information, just like addressing a package with multiple labels added at each stop. This process is known as encapsulation. Let's look at this concept in a diagram. At layer 4, data is created, formatted, and passed to the next layer. At layer 3, we add TCP or UDP headers with port information. At this layer, data is represented as a segment, then passed on to layer 2. At layer 2, we add IP headers with source and destination IP addresses. Data is represented as a packet in this layer and is passed on to the next layer, layer 1. In this layer, we add the Ethernet headers with MAC addresses, and data is represented as a frame, and then it becomes the actual electrical signals, optical signals, or radio waves, depending on the medium of transmission. When it reaches the destination, the process reverses, starting from the bottommost layer at layer 1 up the stack, with each layer stripping off its header until the original data reaches the application, and that is where maybe your browser opens and you see the content. That's interesting, right? Now, let's move on. Let's look at traffic flows. How traffic flows in a network. We will discuss two cases, that is layer 2 switching and layer 3 routing. Let's look at our first case. Two computers are connected to the same switch and are in the same subnet or network. When laptop sends data to PC, it goes through the switch. The switch checks the MAC address table of the destination MAC address and the exit port, and then it forwards the traffic directly to the PC. This is layer 2 switching. The traffic never leaves the local network. It just switched between devices. In our next video, we will dive deep into how a switch builds the MAC address table. So subscribe so that you don't miss out on that. Let's look at our second case. What if these two computers are on different subnets? In this case, the traffic has to go through layer 3 device, which is a router. The router looks at the destination IP address, and then it checks its routing table and forwards the packet towards the right destination. In this case, it is the network that PC belongs to. This process is called routing, and it's how traffic moves between networks or across the internet. So here are the big takeaways from this video. We discussed TCP/IP and how it explains the process of packaging data and delivering it to the right destination. Then we discussed switching, which is used when devices are in the same network, and routing, that is used when devices are in different networks. Understanding this flow is key because in the next video, we'll go deeper into layer 2 switching, how switches learn MAC addresses, what are broadcasts, and how VLANs shape modern networks. This was part 1 of my Networking Foundation series. If you found this useful, hit subscribe so you don't miss on part 2, where we will explore how switching really works under the hood. I'd also love to hear from you. What's that one networking concept you'd like me to simplify in future videos? Drop it in the comment, and if you enjoyed the video, give us a thumbs up. Thank you, and I will see you in the next video.